Hi everyone, today we're going to be solving one-step equations. This is not new. You've been doing this since sixth grade. So not a new concept. Our goal for today is to use the properties of undoing to solve one-step equations. I'm going to pass through this. This is just what we're hoping to accomplish throughout this unit. So as I said, we're going to use the properties of equality, undoing, to solve one-step equations. As you recall, variable equations include numbers, symbols, letters, and an equal sign. That is what differentiates it from an expression, because an expression does not have an equal sign. The equal sign is like a fulcrum on a balance. It's the balancing point. And so an equation will stay in balance as long as what you do to one side of the equal sign, you do to the other. Right now, I have 3 plus 2 equals x plus 1. I mean, just looking at this, we know that x is going to be 4 because 3 plus 2 is 5. 4 plus 1 is 5. But if I threw 3 more over here, if I added 3 more, my scale wouldn't be in balance. This side would be 6, 7, 8. But if I also threw 3 more over here, my balance would remain intact. So as long as you do the same thing to one side of an equal sign as the other, your equation will remain in balance. So where are we at now? Let's see if I can turn my slide. It does not seem to want to advance. There we go. Inverse operations. Let's talk about our inverse operations. What operations undo other operations? As you recall, addition, you would undo addition through subtraction. You would undo subtraction through addition. The inverse operation for multiplication is division, and the inverse operation for division is multiplication. So again, nothing new there. We've done this before. Let's do a quick practice. I have x plus 7 equals 15. Now I think all of you would be able to tell me what x is, but we want to practice using our steps. So our goal is to get this x by itself. So what is over here with the x? We have a plus 7. Well, what's the opposite or the inverse of plus 7? Minus 7. And if I subtract 7 from one side, I need to subtract 7 from the other side to maintain equality. And that just leaves me with x equals 8. And you can test it. You can make sure that it works. If I say x is 8, then where this x is, I should be able to put in 8 and see that 8 plus 7 equals 15. And we know 8 plus 7 does equal 15. So it does check. It is correct. Now you can take it one step further and say 15 equals 15, but I won't make you do that. If you know 8 plus 7 equals 15, that is just fine. Let's look at our next example. 40 equals 25 plus x. For this one, my x is on this side of the equal sign. So over here. So does that change anything? Not really. We still want to solve for x. We want to get this x by itself. So what is over here with this x? Well, I'm adding x and 25. So to get rid of that, I would have to subtract 25 from both sides. If I subtract 25 from here, they cancel out, and I'm left with just x. And 40 minus 25 is 15. Now I could check it again. I could go back to my original equation and say, oh, x is 15, so I should be able to put a 15 here. And is 15 plus 25 40? And it is, so we know we did it right. Forgot to clear my screen. Let's look at my next couple examples. For this one, I have subtraction. I have x minus 5 equals 16. So again, I want to get this x by itself. What do I have to do to get that x by itself? Well, I've got to get rid of this minus 5. Well, what's the inverse or opposite of minus 5? Add 5. If I add 5 to one side, I have to do it to the other. Then I end up with x equals 21. So if I put a 21 up here, is 21 minus 5 equal to 16? Yes, it is. I won't make you check your answers on these ones like this. It never hurts to just plug it in mentally to make sure your answer is correct. But for most of these, you'd be able to solve them mentally. Next one, I have 10 equals x minus 32. Again, I want to get that x by itself. So in order to do that, I have to subtract 32. Add 32. I am subtracting 32. I have to add 32 to both sides. And I get 42 equals x, or x equals 42, which means I would put 42 where the x is. 42 minus 32 equals 10, and it works. Now, there are a couple weird situations you might encounter, and these are ones that cause students problems. I'm going to start with this example because this is one that I've seen many students struggle with. My goal is to get this x by itself. I want to get this x all by itself. Now, people's inclination, they see that minus, so they think they want to add 12 to both sides. Well, if I add 12 over here, then I end up, excuse me, with 12 plus 12, or 24 minus x equals 16. That did not help me at all. What I really want to do is subtract 12 from both sides. I need to subtract 12. Then this does cancel out. And over here, I'm left with 4. But what is left over here? Remember, I had that minus in front of that x. That minus is still there. So I need negative x equals 4. Wow. Well, we haven't done any multiplying or dividing yet. We will get to that in a second. But I can throw a 1 in there, and the opposite, like we know of multiplying by -1, is dividing by -1. So my x would equal -4. I would recommend, if you do something like this, that you probably do want to check them to make sure they make sense. If I have 12 minus -4, do I get 16? If I did just 12 minus 4, I would get 8. I would not get 16. But 12 minus -4, as you recall, when we have that minus a negative, we make that into a big plus, and 12 plus 4 is 16. Now, how else could I have done this? Since, like I said, we haven't talked about multiplying or dividing yet, going to it in a second, but how else could I have solved this? Well, I could have added x to both sides. I added x here and added x over here. I would end up with 12 equals 16 plus x. Either way, this would become a two-step equation. To get rid of that 16, I would have to subtract 16. This cancels out, and I am left with x equals 12 minus 16 is -4. So I got the same answer doing it this way, whichever way you prefer, actually. Neither way is right or wrong. I've already done that, so let's look at our multiplication ones. As I've said, our inverse of multiplying is dividing. So if I have 3 times x, the opposite of multiplication, because that's multiplying, remember, is division. So I need to divide both sides by 3. I'm not dividing by 3x. People always want to think they're dividing by 3x. Then I would end up with an x over here. I don't want that. Just dividing by 3. 3x divided by 3 gives me 1x, which we can just write as x. 15 divided by 3 is 5. Now we could check it. Is 3 times 5 15? And yes, it is. Let's try one more example like this. I have 12x equals 96. Again, I'm just going to divide, because the opposite of multiplication or the inverse of multiplication is division, both sides by 12. X divided by 12 would leave me with 1x, which is just x. 96 divided by 12, see if you know that one, it is 8. Is 12 times 8 96? Yes, it is. Now we have a couple division problems. Let's look at these. I have 12 divided by 2, x divided by 2, not 12. X divided by 2 equals 3. So what number divided by 2 equals 3? Well, to get rid of this division, I can multiply. Multiply by 2. Then you can think of that as 2 over 1. You can simplify before you multiply. Divide by 2, divide by 2, this becomes 1. So I end up with 1x over 1, or just x, equals, and then because I multiplied this side by 2, I also have to multiply this side by 2. 3 times 2 is 6. 6 divided by 2, 3? Sure is. Let's do one more like this. I have x divided by 10 equals 5. Well, again, I'm going to multiply, because the opposite of that division is multiplication. Multiply by 10, multiply by 10. My 10s cancel out. You can write in the ones, you don't have to. And I'm left with x equals 15 times 10 is 150. Is 150 divided by 10 15? It sure is. Okay, I have one more example I want to show you. This is another kind that messes with some students. So let's take a look at it. I have 4 divided by x equals 2. Well, I'm not dividing by 4, so if I multiplied both sides by 4, I'm just going to get 16 over x equals 8. That didn't really help me. I want to get this x by itself, but right now I'm dividing by x. So the easiest thing to do is to multiply by x. If I multiply that side by x, I have to multiply this side by x. This will cancel out. I'm left with 4 equals 2x. It's these type of problems that make you, even though they look simple, it makes you want to check them to make sure you're thinking correctly about these problems. Okay, I'm going to divide both sides by 2 now. And I get x equals 4 divided by 2, which is 2. So let's go back to that original problem. It had 4 over x. We're saying x is 2 equals 2. Is 4 divided by 2 2? Absolutely. So x equals 2. That's it. Have a great day. Bye.